My name is Olivia Myers, and today we're going to be working with problem structures and representing relationships. A lot of times when students first see a word problem, they're overcome with anxiety and distress before they've even read the problem or even attempted to solve it because they're frustrated already, thinking they won't be able to write the correct equation, which will give them the correct answer. And they're right to have some anxiety about it because if it's a subtraction problem and you add it, your numbers can be radically different most of the time, and because they're just not close to the same numbers. Especially can be seriously detrimental as if it's a multiplication problem and you added it, things like that. So today we're going to look at different ways to read through word problems and make sure your students always set up the correct equation. That way, you're going to assure them they will be successful every time. So let's look at this word problem together. Paul Bunyan loves pancakes. He eats 200 pancakes every day. Today, Babe, Paul's pet blue ox, got into Paul's pancakes. She ate 40 pancakes. How many pancakes are there left for Paul to eat today? After you have read the problem as a class, I would go ahead and tell my students to circle the 200, to circle the 40, and underline the last sentence. How many pancakes are there left for Paul to eat today? That last question is really going to help us figure out if we're doing a joint, a comparison, a part to part to whole, or a separate problem. So, have your students write out the 200. This is your start number. And we know we also have the number 40. And we'll put it up here because this is our change. When we read through our last sentence together, it said how many pancakes are there going to be left. So we know that our 40 is going to change our 200 in some way, and it's going to give us our end result. So, we've connected our 40 and our 200 because our 40 is going to change our 200 in some way to give us a result. That lets our students know that they're going to be doing a separate problem. Now, we can't just stop there. What we're going to do now is we're going to break down these numbers into a strip diagram. So you're going to have your students draw a rectangle on their paper. You can also do this by cutting things out and having pre-made strips ready, but for everyday use I would also teach them how to draw it. Now in brackets I have put the 200. This is our start number. This is our whole number. Our 40 is going to change this number in some way. Underneath your 200, go ahead and have them draw a second rectangle in exactly the same length. And they're going to go ahead and put a little mark in it. And underneath that, they're going to make brackets that say 40. And a little question mark. We know now that our whole represents 200. Our second rectangle is representing our whole again, but with 40, we have our 40 here. We want to know how many are right here. Now your high-level, incredibly intelligent students are going to know now by looking at that it's a separate problem and that we've broken it down here, that they're going to be subtracting the 40 from the 200. So we'll go ahead and set that problem up. It's a subtraction problem, so they're going to take it away, leaving them with 160. And we'll go ahead and finish filling in here. As always, with problems such as this, you can have your students double check it by adding the 160 and the 40 together, which will give them the 200. And in word problems, we will go ahead and write out our answer as well. So Paul has 160 pancakes left. And that would be our answer to this problem. Now this is just one kind of way we can solve these problems. This is one type. We're going to look at another type now. Let's read this problem together. Jonah has 10 pennies. Kennedy has 7 pennies. How many more pennies does Jonah have than Kennedy? Again, the first thing I want my students to do is circle the 10, circle the 7, and underline the last question. The last sentence of the question. Because this is, in a weird twist, gives us our question. So, Jonah has 10 pennies. Kennedy has 7 pennies. How many more pennies does Jonah have than Kennedy? Now we know this isn't going to be a joint because we're not asking for the total pennies, so we're not going to combine the 10 and the 7. We know that we're not changing our 10 in any way, so it's not going to be a separate problem like we did before. I just want to know how many more Jonah has than how many Kennedy has. So we know we're starting with our big number. Our biggest number is our 10. And then we also know we have our 7. This is our smaller number. So what we're going to go ahead and do is we're going to go right to the strip diagrams in this one. So we're going to make a rectangle, just like we did before. And in brackets we're going to write a 10. This is our biggest number. And what we're going to do is we're going to compare now. We're comparing. This, of course, is a comparison problem. Whoops, kind of ran out. Comparison right down here. This is a comparison problem. Because now that we have identified our biggest number, we're going to go ahead and take our smallest number and compare it. So again, draw a second rectangle and draw a line in it and write a 7. This is our smallest number here. I want to know what our other smallest number is that's going to equal out our 10 here. We're comparing it. And so by identifying this as a comparison problem, we have our biggest number and our smallest, our 10 and our 7. Our high level and super intelligent students are going to know, thanks to our great teaching strategies that we taught them, to go ahead and set it up 10 minus 7 and subtract it out, and it gives them 3. Now another way your higher students, maybe older students might have set it up is they might have gone, we have our total is 10 and 7 plus x, but again, at the very end, they're still going to be subtracting that 7 here from our 10. So it's essentially the same problem. And like I said with word problems, we go ahead and we write out our answer in word form. So, Jonah has 3 more pennies than Kennedy. The then Kennedy is important because this is a comparison problem. So you need to make sure you include what you were comparing it to in the beginning.